Hello, I'm Charles Low, and it is my personal goal to deliver you the best desktop 3D printer. I think I've done it. Let me introduce you the prototype form of my Octave Light R1. It is easy to use. First, you have to pour some resin into it. This is a fresh bottle of resin. Remember to shake well. Then you can pour the whole bottle into it. And we are using the Maker Juice SF, which is a popular 3D printing resin that you can buy. Here. Then you have to put the build plate into it, which is a piece of metal. Make sure that the build plate is pushed to the bottom and is level. Then you load the 3D model into your computer. Press slice button and then press print. Now the printer is doing its homing sequence. Which means that it has to find the exact location of each of its axes. We are using an optical sensor. Unlike any ordinary 3D printer that uses a mechanical sensor, we are using an optical sensor here. You can see that there may be some bubble on the surface of the resin, but this is okay because our recoater, which is a wafer, will move the bubbles out of the way before our laser detects the surface of the resin. Now we have a laser, and our laser is finding the surface of the resin. One of the features of the Octave Light R1 is that you can print at various surface level. When the resin is higher, you can print, and when you have less resin, so the resin surface is lower, you can still print. The printer adapts to the current level of resin that you have. Now it already detects the surface of the resin. Now it can start printing. Every layer of the model is the thickness of every layer of the model is detected by the laser. So the thickness of every layer is accurate. And we are now printing 25 micrometer per layer. 25 micrometer per layer, and one piece of normal paper. One piece of A4 paper is normally 100 micrometer, and we are now printing a quarter of a thickness of an A4 paper, so our printer is very accurate. So the first layer is done, now is the second layer. Each pixel in the in the our optics is 50 micrometer times 50 micrometer. That means the pixel pitch is 50 micrometer. That's half of the thickness of an A4 paper. And it can print the height of 8 inch. The width is 96 millimeter, and the x direction is 54 micrometer. So the maximum printing envelope for this particular prototype is 203 millimeter. That's 8 inch tall for the z-axis, and for the y-axis is 96 millimeter, and for the x-axis is 54 millimeter. We are using the LED for the light source, and this is ultraviolet LED, so it is very energy saving. It only outputs the specific wavelength that our resin is sensitive to. When I say our resin, that means the resin that we are using right now. This printer is compatible with most stereolithography resin that can be processed by a DLP printer, DLP stereolithography printer. Let me get you closer to take a look at the whole printing process. You can see that our printer is using a top-down printing method, which is the most traditional and the most proven industrial-grade printing method. Unlike the other desktop stereolithography printer available today, they use a bottom-up printing method, which causes stress on the model and destroy the model. Our printing method is top-down, so you do not have to tear the print parts away from any screen. The print part is formed between the surface, the liquid surface of the resin, and the previous already solidified model. You can see that each layer of 25 micrometer thickness is measured by the laser measurement sensor. Each layer is measured. we are printing 3 objects simultaneously, and it is just like boiling eggs. You can boil 3 eggs at the same time that you can boil 1 egg. So printing 3 objects simultaneously will take the same time as printing the tallest of the 3 objects. We are printing an Eiffel Tower, a rook chess piece, and a lattice of 0.5 mm thick rods. You can see the effects when they are finished being printed. The light source of this stereolithography 3D printer is an ultraviolet LED. It has an ultra long lifetime. And in the mass production version of this printer, we will turn off the LED in between the layers. So we only turn on the LED during the exposure time. This will further prolong the life of the LED. The optical engine of this Octave Light R1 3D printer has 1920 times 1080 pixels. That's more than 2 million pixels. The pixel pitch of each pixel is 50 micrometer. That's very fine details you are printing. For your reference, the thickness of ordinary printer paper is 100 micrometer thick. So the thickness of each printing paper can fit 2 pixels. We have just printed 4,724 layers. It takes only 19.6 seconds to print each layer of 25 micrometer thickness. As you have just seen, our top-down printing process is highly dependable and reliable. This is the prototype number 4 of the Octave Light R1. The mass production version will be even more refined and optimized. We will start pre-sales at Indiegogo in March at the pre-sales price of $4,595 each. This is something to look forward to. We will start shipping the Octave Light R1 out of our factory in April 2016. This is a great opportunity for you to help make the Octave Light R1 a great success. Our website, octavelight.com, is under active development right now. More content will be added in the coming weeks. Please contact me by emailing to charles@octavelight.com. So I'm going to clean it and then show it to you. We will first drain out all the resin and then rinse it with alcohol. Then you are going to see how beautiful they are. Oh, and please keep checking our video channels for updates. See you again soon.